Good morning, everybody. Today we're going to continue with sine and cosine and the unit circle. A lot of this is going to be review from last week, but review is always good. So the first thing that we're going to mention is that when you have the unit circle, and if you can pull up this page that I asked you to print out, this is really, really helpful. You have this page handy, it will make all your classwork easier. So the unit circle, again, just as a reference, we're going to keep it up here, is a circle whose radius is 1. So it goes through the point 1, 0 for 0 degrees and 360. It goes through the point 0, 1 for 90 degrees. It goes through the point -1, 0 for 180 degrees. And it goes through the point 0, -1 for 270 degrees. Then back to 360. Also, exceptionally important is to always remember that the x-coordinate is cosine of the angle, and the y-coordinate is sine of the angle. This is never ever going to go away. We have to know this. We also have to know our quadrants and who's positive in each quadrant. You know who's positive, then you know who's negative. So quadrant 1, all functions are positive. Quadrant 2, sine is positive. Sine and cosecant, everybody else is negative. Quadrant 3, tangent and cotangent are positive. Quadrant 4 is cosine and the secant. So that also brings me to my functions. There are 6 of them now. And for my functions, I have sine, cosine, and tangent. And then the reciprocals would be cosecant, wrote that backwards, let's fix that. The cosecant, which would be hypotenuse over opposite. This would be secant, hypotenuse over adjacent, and then cotangent would be adjacent over opposite. So you are going to see a lot of overlap every single day going back to last week, because really last week was the key to it all. You did well on last week's work. This is going to be the nicest unit you've ever done in math, and thankfully it's the unit we're doing at home when we're all not together. Couple of things to always know. Again, like I said to you, these little charts, you can remember the triangles. We're going to be drawing the triangles quite often, but you can also remember the charts where sine at 0 is 1, 0 is 0, 90 is 1, 180 0, 270 -1, and 360 0. Cosine at 0 degrees is 1, 90 0, 180 -1, and 270 0, 360 back to 1. Tangent is sine divided by cosine, so you get 0. Sine divided by cosine at 90, you're undefined. Sine divided by cosine at 180, you're 0. Sine divided by cosine at 270 makes you undefined. And sine divided by cosine back at 360 brings you back to 1. So this chart that I wrote down on our notes for the unit circle day 2, you should definitely have written down. And the one last thing that I never did write down, which I'm going to write down now, is if you draw the radius, which is now the hypotenuse, inside the unit circle with this triangle, this is all about the Pythagorean Theorem now. So here's your altitude, and here's your base, which again, the altitude is sine and the base is cosine, and this is your hypotenuse. So if I take this triangle and I draw it over here, here's my angle theta, here's my altitude, which is the height of y. It brings me up to the y coordinate, which means this is equal to the sine of theta, because it's the y coordinate. And the base, we said, is how far on x we are. It is the x coordinate. We went out x, but we also said that x is the cosine. So the base, let's write that here, base is equal to the length of the x coordinate, because, you know, you had to come out and then go up. That gave us the point xy. And this is then equal to the cosine of theta. And this is the hypotenuse. So if you take the Pythagorean theorem, a squared plus b squared equals c squared, we have what we call the Pythagorean identity. A, altitude, y coordinate sine, so the sine squared of theta, plus b, base, x coordinate cosine, cosine squared of theta is equal to the hypotenuse, but on the unit circle, that was 1. 1 squared is 1. And this is known as the Pythagorean identity. So these things now are what we're going to always keep in our mind. Please know them, and you should also know your 30, 60, 90 triangles. And again, you can also have the table for 30, 60, and 45 degrees. That was from lesson 3 continued, the second day of the unit circle. So if you have those handy, these notes will make everything about our work today a whole lot nicer. So if we take lesson 4, the first page, pretty straightforward. They are asking you on exercise 1, they're saying given the unit circle, well, so here's the unit circle, here it is. And they say given the right triangle, which we drew, find an expression for sine. Well, sine is y, just like we said. Then they say find an expression for cosine, cosine x. So going through, just reminding yourself of your notes, answered question 1. So now they say using the unit circle diagram that you made, or again, knowing your chart. So I am actually going to keep this on the board. I'm going to get rid of this for right now. And I'm going to put as a reference those 2 tables. So if you have sine of theta, cosine of theta, tangent of theta, and we talk about 0 degrees, 90 degrees, 180 degrees, 270, and then we're back to 0 or 360. So I'm just going to stop at 270. These again are the y coordinates as you go through the unit circle. So for 0 degrees, you have the ordered pair 1, 0. That makes this 1 and this 0, but tangent, sine divided by cosine, 0. Now you're at 90 degrees. The ordered pair is 0, 1. 0, 1. 1 divided by 0, undefined. 180, you're at the ordered pair negative 1, 0. So this tangent would be 0. 270, you're at the ordered pair 0, negative 1. So 0, negative 1, undefined. So that, very, very important to know. And again, 360 brings you back to 0. So we're not going to write it again. Now let's talk about the sine of theta, the other chart we had, cosine theta and tangent. And from here we had the 30 degrees, 60 degrees, and 45 degrees. These are from our special triangles, which we have to know. The sine of 30 degrees is 1/2. The cosine of 30 degrees was rad 3 over 2. And the tangent was 1 over rad 3. And we rationalize that to rad 3 over 3. Never are you allowed to give me decimals for these. You have to give me the radicals. They have to be exact. The sine of 60 degrees is rad 3 over 2. And the cosine of 60 is 1/2. And the tangent is rad 3. The sine of 45 is 1 over rad 2, which rationalizes to rad 2 over 2. Cosine, same thing because it's isosceles. And then tangent was 1. So now that we have our important angles that we need to know, we have our quadrants where we're positive, which also now tells us where we're negative. Let's talk about this exercise 2 that wants exact values. Now every time I do these, I draw a picture. I'm always going to draw a picture for everything. I need you to draw a picture for everything. So please, please make sure you're doing that. So letter A has the sine of 30. Well, the sine of 30 is 1/2. If you were to draw it, we're in quadrant 1, so you'll notice that I'm going to start tailoring my picture. Quadrant 1, here's my theta. I am a 1:2 ratio with the hypotenuse. So in quadrant 1, if I draw my special 30 degrees, the sine is 1/2. Letter B. I now have a 240 degrees, sine of 240. Well, 240 brings me to quadrant 3. My 240 landed me here. Now, the 240, big angle, gives me a reference angle of 60 degrees beyond 180. So this is a 60 degree. That means this was 30. So if I label my 30, 60, 90 triangle, I have my 1, 2, rad 3. So this is now equal to quadrant 3 is tangent. I'm talking sine, negative sine of 60. There's my reference angle. So we're pulling it all together. The location, quadrant 3, tells me I'm negative. And I am now the sine of 60 degrees in quadrant 3, the sine of 60 degrees, rad 3 over 2. So again, you cannot just type these in on your calculator. You have to be using your special triangles in the unit circle. They want exact values, and exact is bold-faced. C, they want the cosine of 90. That's the unit circle. Cosine of 90 is 0. Right on the unit circle, it's a quadrantal. So if I draw that, here's my unit circle, here's 90, it's the 0, 1, and cosine is the x-coordinate. And D. D is the cosine of 180, which is also a quadrantal angle, and that's over here. So I might as well just come back. Here's my -1, 0, and again, there's my cosine. So I am -1, exact value. Letter E, the sine of 90. Well, here's my picture still, and this is now, my y-coordinate is the sine of theta, so the sine of 90 is 1. And F is the sine of 135. All right, so now for the sine of 135, I need my picture. 135 lands me in quadrant 2. So here's my 135. Now, I need to reference my 180. So if I went to 135, I had to get to 180. I am a 45-degree angle in quadrant 2. Sine is positive in quadrant 2. So this is now equal to the positive sine of 45. And again, since it's isosceles 1, 1, rad 2, the sine of 45, go to my chart, or I can work it out. I get positive rad 2 over 2. So exact values, no decimals. Letter G, cosine of 150. And then H is on the unit circle. So I'm going to leave that unit circle there. So let me just erase A and B. And let's write G, the cosine of 150. Well, 150, I draw myself a picture that's going to land me in quadrant 2. So here's my 150. To reference 180, I need a 30-degree reference angle. Cosine in quadrant 2. Quadrant 2 is sine's quadrant, so that means I am negative cosine of my reference, which is 30 degrees, and the cosine of 30 degrees, again, if I write it out, opposite 30, 1, 2, rad 3, cosine adjacent to the hypotenuse. Or I can look right up here, cosine 30 degrees, rad 3 over 2. But the location tells me I'm negative. So you have to have your positives and your negatives based upon your locations. And then finally there's H, which is the cosine of 0. Oops, that's not a theta. Cosine is 0 degrees. And here we are, here's 0 degrees. On the unit circle, it's the ordered pair 1, 0, and again, the cosine is my x-coordinate. Cosine is 0, whether you look at the chart, whether you look at the picture. The cosine of 0 degrees for H is equal to 1 whole. So there's the first page. Hopefully you followed along, and hopefully you're saying to yourself, wow, we're basically doing everything that we were doing. Now, the rest, on the second page, exercise 3 exercise 4 has a chart about being positive, negative based upon this. I'll let you fill that out. It's kind of nice to be able to do. But now we're going to start using the calculator a little bit as well. So definitely when you get out your calculator, make sure you're in degree mode, because right now exercise 3 on the back is in degrees. So I need to be in degree mode. So it says the terminal ray of angle, and now they gave you an alpha symbol, drawn in standard position, passes through negative 0.6, 0.8. Now if the x-coordinate's negative and y is positive, that's a quadrant 2. So if I draw myself a little graph, here's quadrant 2, and I have this going to the point negative 0.6 and then positive 0.8. And they're saying it lies on the unit circle. So if this is lying on the unit circle, then which of the following gives the value of sine of A? That would be your y coordinate. So the sine, not of A, of alpha. I just have a hard time drawing that. The sine of A would be the 0.8 because it is the y coordinate, and they gave the words unit circle. Now you jump down to exercise 5. Now they gave us the Pythagorean identity, which I erased, so let me put this back on. And the Pythagorean identity, you can write it either way, sine squared theta or cosine squared theta, because addition is commutative. So I wrote it with sine squared and cosine first. Now I'm writing it this way just to show you. You can write it either way. Addition is commutative. For angle alpha has a terminal ray that falls in the second quadrant. Now, here I am in quadrant 2, where my y is positive and my x is negative. I don't really need all the other quadrants, so you'll notice I really only draw what I need. And the sine is 3/5. So here's my alpha, and they're telling me the sine is 3/5. That means the y-coordinate is 3/5. And they want me to find b. Now, I could use this, absolutely, to find out what the cosine would be, because it's the Pythagorean identity. I'm going to actually show you two ways to go. So if I take the Pythagorean identity, I don't know my x-coordinate, and that means I don't know cosine. So this would be cosine squared theta plus the sine squared of theta, oops, that's a 5, is equal to 1. So x squared plus 9/25 is equal to 1 whole. Now remember, 1 whole is the same as 25 over 25. Just like when we did the rational unit, you use the denominator. And so now the x squared has to be something over 25. And if I subtract 9 from 25, I get x squared is 16 over 25. So if x squared is 16 over 25 and I square root, I get x is 4/5. That was a lot of work. It's like, holy moly. The other thing I can do with this, so this was one way using the Pythagorean identity. The other way is also going to be using the Pythagorean theorem, but it's going to be a whole lot more simple. If the sine of my alpha is 3/5, and I go back to SOHCAHTOA, where sine is opposite over hypotenuse, well, 3 is opposite, and the hypotenuse is 5. I'm in a right triangle. I don't know the base. So why not just use a squared plus b squared equals c squared, where now I have my altitude is 3, I don't know my base, and I know my hypotenuse is 5. So you get 9 plus base squared equals 25. So much easier than thinking through the fractions. Same work. B squared is 16, so therefore B is 4. And if that's the case, my x-coordinate now, because now they want the cosine of alpha, and cosine, so now I'm going to come down over here, cosine would be adjacent over hypotenuse. So the cosine of this alpha would be 4/5, which is exactly what I got here because x is cosine. So here, a little bit simpler with the Pythagorean theorem. If you can label a triangle from your function, and then you still have to find the cosine, use the Pythagorean identity, you're at the cosine immediately. So that's kind of nice. Let's try another one. Let's do example number 6. Exactly like this example number 5 rather. But now they changed the value. So let's just get rid of this whole thing and we'll write out. And I believe they said that the cosine was 1/3. Of course, I dropped all my papers, so that doesn't help me. All right, and we're in the first quadrant. All right, so we are in quadrant 1. Again, I don't really need everything else. Positive x, positive y. And I know they're using, oh no, they're using theta on this one. Good, because I really can't draw the other one. So we're on the unit circle, and they're telling me the cosine is 1/3. I don't know the y-coordinate, which means I don't know sine. So cosine of theta is 1/3. And again, from my SOHCAHTOA, Cosine is adjacent over hypotenuse. So my 1 is the adjacent side and 3 is my hypotenuse. I don't know the opposite side. This is my A, and I can use a squared plus b squared equals c squared. I can say a squared plus 1 squared is equal to 3 squared. So a squared is equal to 8. 9 minus 1 is 8. So a is the square root of 8, which simplifies to 2 rad 2. So they want the sine of theta is now opposite 2 rad 2 over the hypotenuse, which is 3. And there I have number 6 done. If I decided to not use the Pythagorean theorem this way, and I went with the 1/3 and the Pythagorean identity, so option B now would be cosine squared theta plus sine squared theta is equal to 1. I have 1/3 squared plus my sine squared theta is, I'll just write sine squared theta because no abbreviation for that. And that's 1. This is 1/3. And 1 with the 3 would be 3/3. So this gives me sine squared theta is equal to 2/3. And now I have to take the square root. 9 rather, sorry about that. Let me erase that and fix that. Sorry, I'm going too fast. 3 squared is 1/9, and so this one should have been 9/9. So sine squared theta is 8/9. And again, you have to square root. So now I am at the sine of theta would be the square root of 8 over 3, because square root of 9 is 3, but then square root of 8, 2 rad 2. Either way, you're getting the same answer. It's always beneficial to know more than one way. So today I want you to do the second page. Do your best, rewind, go back through the video, look through all your notes. And if you have all these notes in front of you, you're going to be just fine. But again, email me with all your questions, all your concerns. I will absolutely answer you as quickly as I can. Good luck.